Hello guys, Axel here, and welcome to Lying Buttons. This is what the module will look like. Each of these big black boxes will have a statement about the entire state of the board. However, some of them will be lying, and of course some of them will be telling the truth. Our goal is to figure out which ones are telling the truth and pressing the coloured buttons of those ones to start the module. The amount of liars is determined by the clamps on the side of the module, where top left means 1, top right means 2, bottom left means 3, and bottom right means 4, with multiple ones meaning it can be one of the two, but not the ones that aren't there, basically. The boxes on the side of these buttons are just used for note-taking, like it's stated here. And you can fill them in with 1, 2, 3, 4, 5, O and X, and empty. So, without further ado, let's just get started. So let's first note down the conditions we have, the possible conditions. So first of all, the amount of liars, before you even get to these ones. We have the top left and the top right, which we can see here, means we have 1 or 2 liars, which can actually be used to discount certain possibilities. If, like, saying 1 to false means you get more falses that take you over that limit, meaning that can't have been a lie to begin with. But let's note down what each of these statements means, using this clue elements table to show, or diagram, to tell you what each thing means. So this top one means top row has no liars. The second one means specifically the bottom left isn't lying. The white circle, as you can see though, just means the total amount of liars, irrespective of the colour. The third one is actually the same as the first one. The top row has no liars. The fourth one is the right column has 2 liars. The fifth one is saying the bottom right is lying. That's probably a good starting point, just to see. The sixth one is saying 2 reds are lying. At most, 1 middle column, 1 is lying. So none or 1 of them. Top middle isn't lying. And the last one is that the blue liars is greater than the red liars. So now we just have to figure out what combination of trues and falses here gives us a valid grid. So let's start off with some of the ones that give a specific sort of general case for the. Sorry for this. Start with one of these ones that give a concrete value of one of the squares. So let's start with the one that says that the bottom right one is a liar. So of course this makes this one false, and this one true even, which implies this one's false, which means that in fact the blue lie is not greater than the red lies, it's either equal to it or less than it. That didn't really give us much. So maybe let's try something else here. So saying this one's a true means this one's telling the truth, which then means this one's telling the truth. That one tells us that at most one is telling a lie in the middle column. That is currently true. So let's try something else again. So the only chance for red to be both telling lies, have two telling lies, is if this one and this one are telling lies. But then if this one's lying, then this can't be the case. So maybe let's set that one to false, which then implies this one has to be true. So which tells us that there's no lies in the top row, which makes that one true. And as we can see here, the last column has two liars, so that's true as well. So do we have a valid grid here actually? I've actually just stumbled across the correct answer straight away. So let's see. So the top row has no liars, we can see that's true. So that means 1 and 3 are fine. The bottom left is telling the truth, which is true. The last column has two liars, that's true. The bottom right is lying. Let's look at this one then. The blue liars is greater than the red liars. The liars we have are red and blue, which is equal, so that's false, which we expected. This is also false like we expected. Middle column has less than or equal to one liar, which we can see 0 is in fact less than or equal to 1. And the top middle is telling the truth, which we found out is true. So since we've figured out a valid grid, we're going to be pressing all the buttons that are telling the truth, so it's basically all of them but these two. And we get a self-module, where the module completely disappears. So let's do another one. So in this case we have 1 of 4 liars. So what I didn't say on the previous one here was if you noticed, when I reached 2, I knew if I got any other rules that said liars, then I know I was on the wrong track, basically. But let's note down the conditions again. Oh, funnily enough, we actually have 3 identical conditions here. Those being bottom and middle rows. The bottom has more liars than middle row. We'll be seeing that 2 more times. We then have there's at least 1 red liar. Red liars is greater than yellow liars. There's 1 liar in total. This rule again. Middle right is telling the truth. All 3 colours have liars. The same condition again. And finally, middle is telling the truth. So since we know it could be 4, let's start with assuming that all 3 of these are lying. So take all these to false, which would then imply this one was lying as well. So we have 4, so let's see if the rest of them can be true without breaking it. As we can see, no it can't, because that would mean that the bottom left one was lying as well. So then we would have 5 liars. So that gives us some crucial information that all 3 of these were telling the truth. So we now have a vital bit of information that the bottom row has more liars than the middle row, and it's not tied. So that means we either have 2 on the bottom, 1 in the middle, or 1 on the bottom, none in the middle. So let's see. So by default, if this one is true, it means this one's also true. And since we know that that rule is true, it means that this one has to be false, which we can see. Since we actually can't see it yet because we still have available ones for all colours. But knowing that gives us a possible inkling that the blue one here is also true, to remove that factor. I just realised that one's actually referred to itself. So, funny enough, if that one's telling the truth, it's telling the truth. And if it's lying, it's going to be lying. So at least it didn't create some sort of paradox or something. So, 1 liar in total. That could be true. Let's assume that's true for now, which would then imply everything else is true. Does that make sense? So, bottom row is greater than the middle row, yes. There's at least 1 red liar. We do have at least one red liar. Red is greater than yellow liars. That is also true. There is only 1 liar. That's true. The button itself is telling the truth. That's true. Bottom left is false. And in fact, yes, we don't have all 3 colours. And the middle one is telling the truth, which is true. So I actually think we've got the answer here. The only one that was telling a lie is the bottom left one. All the other ones are telling the truth. So let's see. There we go. So it is partly guess and check. The only one of these symbols we didn't actually have is this one here. Number of liars are orthogonally adjacent to another liar, meaning for the middle one that would be the one above it, the one to the left of it, the one to the right of it, and the one below it. Which definitely could be a very helpful clue. If you don't know if 2 of them are lying or telling the truth, that one might tell you that one of them just is impossible to happen. But as you can see there, you can generate duplicate clues for all of them, which is actually really helpful to eliminate possibilities. If setting all of those to true would remove the possibility of other ones, and simply would set them all to false. But if 2 buttons have the same condition, I think that more often than not, or just never not, they will have the same value. I don't think there's a case where different buttons can have the different values just by having the same condition, because that would defeat the point of the module, I think. And as you can see, I didn't really mention it, but we knew that we had at least a viable solution, because we did only have 1 liar. And then remember, we started off assuming there was 4 by saying the 3 that were same to false, but then that caused problem later on. So we could have safely assumed that there was 1, but there was still obviously a possibility of there being 4. So hopefully you somewhat understand how to approach this module more. I'll see you guys in the next tutorial. I'll see you later.